Great people, welcome to NameTech channel. My name is Nehemiah, and this is lesson 8 on Pandas. We are going to discuss data correlations. But then before we begin, if it's your first time to get into this channel, or if you have never subscribed to this channel, please take a second or two, click that red button, the subscribe button. And to the returning subscribers, thank you very much for your continuous support. You can as well like the video so that we may reach very many people. So guys, basically a great aspect of Pandas module is the core method, and basically the core method calculates the relationship between the columns in your data set. Now talking about data set, I have here some data set here in this Excel file. In this Excel sheet, I have some data here, data set that I'm gonna use in this tutorial to teach you. However, the data is in this folder in the disk C, in this drive C. Now, before anything, when working with modules, is to import what? To import the code library itself, the module itself. Import pandas spd alias pd, and then now here we are going to import what? We are going to import now the CSV file. It is df. Let me define that variable with the df, then assign it to this data frame pd dot read underscore csv file, and then here guys, I'm gonna pass what? I'm gonna pass this file path. And sure guys, you copy the file path here, and then do what? Add it here in your these rounded brackets. Then I think this is backslashes. Ensure that it is in a pair, others will have an issue at the terminal. Ensure that you have a pair of backslash, also here a pair of backslash, also here a pair of a backslash. I don't know if it is forward slash or a backslash. I don't know, but then ensure that you have that thing. And then here print, to the print function, let me say print. We are going to use the core method here, but then before then, ensure that we have the variable here. We are going to pass the variable here, and then also we are going to use this method core method. And then what I do, let me run the codes. Let me run these codes here, and then guys, basically you can see that we have printed out some values here. So guys, basically these are core method ignores the not numeric columns. But then guys, let's now discuss these outputs here, or the results here in much details. So guys, basically the results of this core method is a table with a lot of numbers that represent how well the relationship is between two columns. So guys, the number ranges from our -1 to 1. Now guys, basically let me just go through briefly. So guys, basically whenever you have a 1, like here, whenever you have a 1 in your results, then that means that there's a perfect correlation. I mean, if you have 1-to-1 relation, like here, duration to duration, 1-to-1 relationship, then that's a perfect relationship. And for this data set, each time a value end up in the first column, then on the and then guys, basically the other side also end up well. Now in another case, for example, if you have 0.9, like in this duration calories column section, basically if you have a 0.9 like this one, then this is a good relationship. Now if you increase one value in this case, then probably the other will also increase. And if you have a negative, now this will mean that it's just as good a relationship as 0.9, but then if you increase this one, then the other one will go down. When you increase this one, the other one goes down. Now if you have basically 0.2, then that will mean that it's not a good relationship. Which means that if one value goes up, then it does not mean that the other one will increase, or you cannot predict. And so guys, basically how do you know that this one is a good correlation. Now guys, basically it depends on the use, but I think it is safe to say that if you have at least 0.6 or negative 0.6, then you can call it a good correlation. And so guys, basically let's talk about the perfect correlation. Like you can see in the duration column we have 1. So guys, basically this is an example of a perfect correlation, which makes sense. Each column always has a perfect relationship with itself. So and then a good correlation is, for example, the duration in the calories. I gave you that example of a 0.9. Basically when you have a 0.9 or so correlation, then it's a very good correlation in that you can predict that the longer you work out, then the more calories you burn on your body. And then the other way around, if you burned a lot of calories, it means that you probably had a long workout. So that is a good correlation. Now the bad correlation, an example is duration versus the max pulse. You can see that the value is 0.009403 correlation, which is a very bad correlation, meaning that you cannot predict the max pulse by just looking at the duration of the workout, and vice versa. So guys, basically this is what I wanted to show you in this Pandas data correlation tutorial, and I think you've gained something. Please consider subscribing, like and share the video to your friends. Until next time, this is Nehemiah. Goodbye.